Troubleshooting Fortigate. Let's take a look at some example scenarios for issues that you could meet on day-to-day life with the Fortigate firewall, and we can see easy way to fix each of them. And first we have this Ubuntu client that cannot connect to the internet. We want to troubleshoot this issue. It's going to be helpful for us if we can monitor the traffic coming out of this machine. So from our Fortigate using the CLI, we have a very useful feature. It's called Sniffer, and it allows you to monitor traffic in real time, and you can see a lot of useful information that can help you troubleshoot the issue. And we will put the command Diagnose, Sniffer, and then packet. So these are three static words, and then the next filter you need to put is your interface. You can put things from any for any interface, where you can put a specific port 1, port 2, port 3, port 4. And here we can define our filter. We can choose to put filters such as host or network or port, and we can be very granular, or you could just close your filter directly and this will show you all traffic from all protocols. But this will show us a lot of noise. So first we need to define at least our client, which is 10.0.10.5. This will monitor all the traffic coming out of our Ubuntu client. And the final step is to define the Verbose level. And this has a different levels that shows you more information per your need. The most common used one is number 4. This will show you the main information about the packet and the interface names. If you want to see the full details of a packet, you can choose number 6, which will show you a lot of content. So in this case, let's do number 4 and we hit enter. Now we have our filter running. First, we can stop our filter by putting Control C, and we can watch here our client trying to send traffic to the public IP address of the website. So this is our incoming interface. This port 3 on our Genus 3 example is going into our Ubuntu client. So in this case, the traffic comes from port 3, it goes to the firewall, and it's supposed to go to port 1 to get to our internet. So from here, we see our DNS traffic going also to resolve the name, and we can see the port is 53. So we know this is DNS traffic. We see that the DNS server responded back to the client. So there's two-way traffic in the DNS and it works fine. But our 443 and 80, which is web traffic, which is the website we are trying to open here, it's just showing SYN and there's no complete TLS handshake happening. There is no communication coming back from the web server. So we can also use a different diagnose feature in addition to the sniffer, so we can get more better visibility on why this connection is not working. So the command we will be using now is diagnose. We will add debug. And since we are trying to capture the flow of a specific client, this feature is called flow. And then we can add a filter. And filters in this case, if I put a question mark, we can do things such as source address, destination address, or IP address, wherever it is, source or destination. We can put a specific port as a source or as a destination. So in this example, we can use source address. Since we are monitoring traffic coming from the Ubuntu client, we can put the same filter, source address 10.0.10.5. And now we have our debug flow filter set. Now we need to enable this flow to start. So we can enable diagnose, debug, flow, trace, start. And this way our flow has been start tracking our traffic. And once the trace start working, we see already here a more detailed version on the traffic flow. We see things like protocol. We know this is UDP protocol because of number 17. This is our source address and source port going into this destination address and destination port. And this is the DNS session coming from port 3. The first thing the firewall did is it allocated a new session for this client in the session list, and it allowed it by policy, and it shows us which policy number. It lets us know that there is a SNAT enabled because this is in our net outbound. We are running NAT to the outgoing interface. So now if we try to refresh the page and I go back to my body client, I'm now seeing another line after the DNS session, and now I see the traffic going into google.com IP address on port 80, coming from port 3 as well. And it did still allocate a new session, but if we look here, our message is referring to a denial by forward policy check, policy 0. And policy 0, as we know, is the implicit deny. So that means there is no allow policy for this web traffic to go through. So now we know that we have an issue on our policy. We have to go and modify our policy to allow this. But first, we can also stop our trace by putting the command diagnose the bug flow trace stop. In this way, you are not putting additional load on your kernel for no reason. Now I modified the policy and added the services. We can see here the traffic start working immediately. Now we can do it the other way around by putting a sniffer on port 3 as well, but instead of filtering by our source IP address, we can filter on all web traffic in general. We can put a new filter for our port, and this will be port 80, and we can say or 443. So this way we are putting HTTP, HTTPS traffic filter, and we can put our filter again. You can also limit the number of results if you don't want to see a lot of information in the screen. After the verbose level, you can add the number of packets that you want to show in this list. So for example, if I put only 20 lines and I hit enter, and once I load another website, as we see here, when there is a configured firewall policy, there is a proper TLS handshake, there is a first flag, there is the second flag, and this is the final acknowledgement. And if your session is working fine, this is how the TCP handshake would look like. It only showed me the portion that I needed by showing me 20 lines as I specified, so it didn't overwhelm my screen by too much information. Now let's do another filter in here as well, so we can see different scenario. We can put diagnose sniffer packet. And instead of port 3, we can just leave it to any, and we can open our filter, and instead of searching by the client, by the IP address, we can search by the whole network. And the filter for this would be net, and then we can say 10.0.10.0/24, and we close our filter. This time we will choose Verbose level 6 to see how would it look like with all the information showing on the screen, and we will limit this only to 5 packets. And the L flag will just add a timestamp next to each line so you can know which time did this traffic happen. And finally we hit enter. Now it has a timestamp next to each line, the incoming interface, and IPs as usual. And this is the hexadecimal format for the packet data. You can actually take these lines and convert it using a specific CLI script, and it will make a PCAP file that you can read in Wireshark using this tool. Now if you are trying to troubleshoot a session on the firewall, there is also another way you can view your existing session, and the command for this would be diagnose system session list. And now it's going to show you all the sessions that are running on the firewall. This is the total count, and it shows you all the addresses and return addresses for each session. We are trying to diagnose a specific session. We can search the session by a specific filter. So for example, we can put filter, and with the same parameters we put on the diagnose debug flow, we can also add filters in here such as destination port. We can put port 443. And then if we put the same command session list again, it will show us only the 443 sessions in here. And in this case, we can issue the command diagnose system session. And if I add a question mark, I have a clear option. So if I put the command clear, this will kill all the 443 sessions that I define in my filter. So if I list the 443 sessions again, instead of 4, I'm now down to 0. So if you had an issue with a specific session that was hung or freezing, you can use a filter to specifically define this session, and you can kill it using the command diagnose system session clear. Now let's try to diagnose our VPN that is not coming up. Under IPsec monitor, you can see the status of all your VPN tunnels. And for this specific one, we see no data incoming or outgoing. Our phase 1 is down and our phase 2 is also down. So the best way we can diagnose this is we can go into our CLI system. We will use the command diagnose VPN IC, and then we can add our log filter. And in here we can add different kind of filters, very similar to the ones we've seen before. We can search by things such as our interface, our source address, destination address. We can add the filter destination address and filter on the remote gateway of our VPN tunnel, which is 192.168.1.123. Now that we have our filter set up, we need to enable the debug for the IC application. Diagnose debug application IC -1, which shows us all the information, and we notice that this will only run for 30 minutes because this adds up a load on the device and it doesn't want you to keep it running forever and forget about it, and then it's gonna keep putting the load on the kernel. And finally, we need to enable our debug by putting the command diagnose debug enable. Now our debug message is showing ignoring request to establish IPsec security association, no policy configured. So if you didn't have any policy tied to your VPNs, they will not come up. This is very important rule of the VPN tunnel. So first we need to establish a firewall policy to allow this traffic, and then the firewall will start trying to negotiate for IPsec tunnel. Now once I edit a policy that include the VPN interface in either the source or the destination, I check back, now it's showing me a lot of information. The error that is showing is pre-shared secret mismatch. I mean the password or the PSK that you assign to the tunnel does not match between both sides. And that's why there is an issue communicating on this IC traffic. So we need to make sure that our password match. Now we see different input because now we are negotiating phase 2 of the tunnel. That means we at least have phase 1 up. We try to refresh our page. We indeed have phase 1 and phase 2 up. And that means the issue that we had, that the pre-shared secret was mismatching, that's why the tunnel did not initially come up. Another scenario where the VPN traffic might not come up, in this example we are getting an issue, no security association proposal chosen. That means the phase 2 of the tunnel has failed to negotiate. We have to see what information is mismatching between each side to make sure that we are matching all the parameters between both sides. The first 2 proposals on the top are my proposal. This is what is configured on my side, and the incoming proposal is the other side or the other FortiGate I'm trying to VPN with. The protocol ID matches, the BFS group matches, but the transaction or the encryption is choosing in different format. I'm using DES encryption on the first side, and the second side I'm using null. So I'm not using this encryption, and this way phase 2 is not coming up. And once we match the information, the tunnel will come up, and we can see that our proposal matches with the other side proposal. And this way it would say negotiation result. This is the proposal ID that got accepted, and this is the information inside of it. And it will show us all the information such as the encryption domain, the SPIs, and all that information. So this has been a successful negotiation, and now the tunnel is in up status. You always want to make sure that you configure the same parameters between the VPNs on both firewalls to make sure they can negotiate successfully. And that wraps up our Introduction to Fortigate course. Thank you so much for making it to the final video of this course. If you want to learn more about the Fortigate, you can also check the Advanced Fortigate Configuration course. And I will see you next video. Thank you.